partial fraction, integration by parts. There we go, sorry.
Wow. Should we do a retake? Yeah, here's a retake.
No retake. Okay.
Leave it in, it's okay.
Leave it in, it's bloopers. We should make like a fake bloopers reel from like my classes this year.
Do the Mr. Goodman's law.
I don't know what that is. Okay. So here's where the formula comes from. Do you guys remember the product rule?
Yes.
So if I want to take the derivative of uv prime equals what?
U prime times
U prime v, the derivative of the first one times the original second, plus the original first times the derivative of the second. Okay? All right? Ready? Ready? All right. If I take this formula, if I take this equation, I'm going to take the antiderivative of both sides. Yeah, exactly. Take the antiderivative of both sides. The antiderivative of uv prime is just what? uv, u times v. Okay? What I'm going to do, the integral of a sum is the same as a sum of two integrals, right? So I'm just going to put another integral symbol here, and I'm going to subtract over the integral of uv prime. Wait, no, I'm going to subtract over... I'm going to subtract over the other one, sorry. Subtract over the integral of u prime v. So I get uv minus the integral of u prime v equals the integral of uv prime, okay? The way this is commonly written, this is a formula, this is a big hitter, this is a pink sheet. The integral of u dv equals uv minus the integral of v du. That's the formula. It works sometimes.
In college, is this all considered like Calc 2 stuff?
This really is Calc 1. I was surprised when he said it wasn't in AB.
And specifically for the University of Mathematics.
Okay. So here's how I do this. Okay. I gotta note first that this antiderivative here is the product of two functions. What are those two functions?
X sine
X
X.
and sine x, right? Now, if only that pink part weren't there, this would be a lot easier, right? That's what I'm thinking, okay? How can I maybe make it go away? What's the derivative of x? Just 1. So if I take its derivative, it just becomes a 1, right? So what I'm going to do, I'm going to label my x, I'm going to let that be my u, okay? And then I'm going to let that sine x be my dv, okay? I've got to pick one to be u. I've got to pick another function to be my dv, okay? So u equals x. Let me do this color-coded. U equals x. What's the derivative then? What's du going to be if I take the derivative? It's going to be 1, just 1 dx, right? Okay, and then for the blue part, I know dv equals sine x, so what am I going to do with this? Find the antiderivative. That will give me v. The antiderivative of sine x is what? Negative cosine of x. Okay, and then I just plug these into the formula, okay?
Wait. Why does du equal 1 dx?
So if you look at this, the u equals x equation right there, if you take the derivative of both sides, you get du dx equal, okay, yeah. All right, and so then this integral, I had the integral of u dv, so now I'm just going to write u, my answer is going to be uv minus the integral of v du. So I just start plugging stuff in. What's my u here? X. What's my v? So x times negative cosine x. Then I have a subtraction symbol. And then I have the integral of, what's v du? What's v? Negative cosine x. Oh, shoot. Negative v du. Negative cosine x dx. Okay. These two plus signs are going to cancel each other out, or these two minus signs are going to cancel each other out, so it's going to be a plus antiderivative of cosine x. What's the antiderivative of cosine?
Sine.
Sine. You guys are actually all wrong. It's sine x plus c. That's my answer. Okay. Questions on how we do that? Yeah. The creativity is picking which function to be your u and which one should be your dv. Sometimes you'll get the answer either way and it will work out. Sometimes it'll only work if you pick the right u and the right dv.
So what's the point of u and
Right, when you're trying to find the integral of something that's two functions multiplied together, and like a u substitution doesn't work, you use this formula to allow you to rewrite the antiderivative in a different form that's easier to find.
So wait, how do we find v? Where did v come from?
V, you pick your u and your dv, so we picked u to be the x there that we saw, and we picked dv to be the sine x that we saw, and then we found v by taking the antiderivative of both sides of this equation. So if I take the antiderivative of dv, that just gives me v. If I take the antiderivative of sine x dx, that just gives me negative cosine x.
What's the point of
Du then, so the formula demands that I do uv minus the integral of not just v, but I also have to include my du.
So that's the formula.
Yeah. This is the Bible for this. Okay. The du then, I pick my u, right? I get du just by taking the derivative of both sides of my u equation. Thank you. Good question. Okay. So that's integration by parts. Do you guys want me to do another one? Okay. That's plenty of time. Okay. So, right, this would be a lot easier, right, if we didn't have the x there, right? So, usually you want to pick as your u the one with like the neater derivative, right? Derivative of cosine 5x is negative 5 sine 5x. Derivative of x is just 1. So what do you think we want our u to be?
X.
We want to pick x to be u. We want our dv to be cosine 5x dx. So u equals x. What's du then? Du is just dx. dv is what? And then what's v?
Negative 5 sine 5x.
Yeah. Wouldn't it be negative 1/5? And it should be positive, right? Positive 1/5. Positive, right? Because that becomes cosine 5x times 5. You okay? What? The u sub. So this is like its own problem unto itself. Integral of cosine 5x dx, right? I've got a function 5x nested inside of another function. So I set u equals 5x, du dx equals 5, du equals 5 dx. So I need there to be a 5 here, so I do 5, and then I have to write a 1/5 to compensate. This and this become du.
So you did a u sub trying to find the antiderivative.
Yeah. So this is like its own problem almost. Okay. That's how I did that. Thank you, Miss Taylor. Anytime. I make you like the class anti-deriver.
I didn't do that. I just made things.
So then the formula uv minus the integral of v du, we just plug stuff in, okay? So u times v, right? Multiply these two together. X over 5 sine 5x minus the integral of v du, which is the integral of 1/5 sine 5x dx. Okay. This one, what I would do is I would pull out the 1/5 and do another u sub. So we should probably do that on the board. Yeah. What's that? Yeah. So here. I'll just do that on the board real quick.
Wait, why at the end? Why is it dx? If the formula said du. Oh, never mind.
Got it. Okay, so let's do that antiderivative together real quick. Antiderivative of 1/5 sine 5x dx. Right? Let's pull the 1/5 out because I'm allowed to do that since it does not depend on x. Okay. 5x, that's a function, right? It's nested inside of my sine. So what do? U equals what? Du dx equals what? 5. Okay, so du equals 5 dx. Okay. So I need there to be a 5 here. When I put that 5 in, I've got to put what out here to compensate? Another 1/5. Okay. What's this antiderivative give me? Is that negative cosine 5x? Negative 1/25 cosine 5x plus c.
Mr.
What was
Rushton?
your first step?
First step in the whole problem?
No.
Oh.
From there.
What is your first step?
Oh, what I did here?
Yeah.
I just took that antiderivative on the board for you guys. That's one you can do without the u integration by parts. You can just do it with u substitution.
On both sides or just
Wait, sorry, what?
like did you find the antiderivative on both sides?
No, this one you just leave it. That's just part of the answer. Yeah, that's just going to be the first term. So I was just trying to simplify the second term.
Mr. Rushton, what was your first step?
Okay, so then that would be what? It'd be minus that antiderivative. So it ends up being a plus 1/25.
Mr. Rushton?
So we can work on these in class. You can work on them at home. We can play spike ball. Whatever you want to do.
So can we just like everybody does it, or if
Everyone does it.
Well, we didn't want to class,
All we play spike.
Can you post the answers?
Yeah, let me see if I can find them. I'm sure they're on Mr. Shadio's Schoology somewhere.
Mr. Rushton, would you mind